Underscore next underscore in generators and iterators, and what is a method wrapper? I was reading about generator and iterators and the role of underscore next underscore. Underscore next underscore in Dear Megan is true. Underscore next underscore in Dear MyList is false. As I looked deeper into it, underscore next underscore in Dear MyList dot underscore iter underscore is true. Why is underscore next underscore only available to list but only to underscore iter underscore and Megan but not MyList? How does underscore iter underscore call underscore next underscore when we are stepping through the list using list comprehension? Trying to manually step +1 up the generator, I called Megan dot underscore next underscore. It doesn't exist. It only exists as Megan dot underscore next underscore, which is called method wrapper. What is a method wrapper and what does it do? How is it applied here, in Megan and underscore iter underscore question mark? If underscore next underscore is what both generator and iterator provide, and their sole properties, then what is the difference between generator and iterator? Answer to 3, solved, as noted by mod/editor. Difference between Python's generators and iterators. Update: both generator and iterator have underscore next underscore. My mistake? Looking at the logs, somehow, Megan dot underscore next underscore test was giving me stop iteration exception error. But I wasn't able to duplicate that error again. Thanks everyone for answering.
The special methods underscore iter underscore and underscore next underscore are part of the iterator protocol to create iterator types. For this purpose, you have to differentiate between two separate things, iterables and iterators. Iterables are things that can be iterated. Usually, these are some kind of container elements that contain items. Common examples are lists, tuples, or dictionaries. In order to iterate an iterable, you use an iterator. An iterator is the object that helps you iterate through the container. For example, when iterating a list, the iterator essentially keeps track of which index you are currently at. To get an iterator, the underscore iter underscore method is called on the iterable. This is like a factory method that returns a new iterator for this specific iterable. A type having underscore iter underscore method defined turns it into an iterable. The iterator generally needs a single method, underscore next underscore, which returns the next item for the iteration. In addition, to make the protocol easier to use, every iterator should also be an iterable, returning itself in the underscore iter underscore method. As a quick example, this would be a possible iterator implementation for a list. The list implementation could then simply return list iterator self from the underscore iter underscore method. Of course, the actual implementation for lists is done in C, so this looks a bit different. But the idea is the same. Iterators are used invisibly in various places in Python. For example, a for loop. This is kind of the same to the following. So the for loop requests an iterator from the iterable object, and then calls underscore next underscore on that iterable until it hits the stop iteration exception. That this happens under the surface is also the reason why you would want iterators to implement the underscore iter underscore as well. Otherwise you could never loop over an iterator. As for generators, what people usually refer to is actually a generator function, i.e. some function definition that has yield statements. Once you call that generator function, you get back a generator. A generator is essentially just an iterator, albeit a fancy one, since it does more than move through a container. As an iterator, it has a _next_ method to generate the next element, and a _iter_ method to return itself. An example generator function would be the following. The function body containing a yield statement turns this into a generator function. That means that when you call example generator, you get back a generator object. Generator objects implement the iterator protocol, so we can call _next_ on it, or use the next function as above. Note that the first next call did not print anything yet. This is the special thing about generators, they are lazy and only evaluate as much as necessary to get the next item from the iterable. Only with the second next call, we get the first printed line from the function body. And we need another next call to exhaust the iterable, since there's not another value yielded. But apart from that laziness, generators just act like iterables. You even get a stop iteration exception at the end, which allows generators, and generator functions, to be used as for loop sources and wherever normal iterables can be used. The big benefit of generators and their laziness is the ability to generate stuff on demand. A nice analogy for this is endless scrolling on websites. You can scroll down item after, calling next on the generator, and every once in a while, the website will have to query a backend to retrieve more items for you to scroll through. Ideally, this happens without you noticing. And that's exactly what a generator does. It even allows for things like this. Non-lazy, this would be impossible to compute since this is an infinite loop. But lazily, as a generator, it's possible to consume this iterative one item after an item. I originally wanted to spare you from implementing this generator as a fully custom iterator type, but in this case, this actually isn't too difficult, so here it goes.
Why is _next_ only available to list but only to _iter_ and Migan but not mylist? How does _iter_ call _next_ when we are stepping through the list using list comprehension? Because lists have a separate object that is returned from iter to handle iteration, this object's _iter_ is consecutively called. So, for lists. While, for generators. In looping constructs, iter is first going to get called on the target object to be looped over. Iter calls _iter_ and an iterator is expected to be returned. Its _next_ is called until no more elements are available. What is a method wrapper and what does it do? How is it applied here, in Migan and _iter_? A method wrapper is, if I'm not mistaken, a method implemented in C. Which is what both these, iter_list._iter_, list is an object implemented in C, and gen._iter_, not sure here but generators are probably too, are. If _next_ is what both generator and iterator provide, and their sole properties, then what is the difference between generator and iterator? A generator is an iterator, as is the iterator provided from iter_l. It is an iterator since it provides a _next_ method, which, usually, when used in a for loop, it is capable of providing values until exhausted.
_next_ and _iter_ are method wrappers for when you do next some _gen, or iter some sequence. Next some _gen is the same as some _gen._next_. So if I do Migan equals iter mylist, then Migan is mylist implemented as a generator object and has a _next_ method descriptor. Lists themselves do not have this method because they are not generators. Generators are iterators. Check out difference between generators and iterators.
If you want to see more, please consider subscribing.